Well, hi everybody. Welcome to the recording for programming week 2. And in this recording, you'll see I'm writing the announcements. I'll click right here, and in week 2 we're going to jump right into starting to learn about programming. Of course, in week 1 that was just introduction into how the course works and things like that. But now you're going to actually get in and do some work. So I clicked on the week 2 announcement, and you can see that it lists everything that we're doing for this week. So you watch the weekly lesson recording, which is what you're watching now, and you'll complete the Class Connect write-up, and I'll show you how to do that. Then for the week, I broke, just like I do for every week, I schedule things on Tuesday and Thursday. So however you want to do it, you can, but I think it's easier to have it broken down. So for Tuesday, your goal by the end of Tuesday should be to have these items done. Then your goal by the end of Thursday would be to have these items done. Now some students, they take it to mean that, okay, on Tuesday I'll start these things. So Tuesday and Wednesday get that done. And then Thursday and Friday do this stuff. Doesn't matter to me at all how you do it or when you do it, as long as you get it turned in by the 26th. So you have until the Sunday of that week to get the work done. So however you want to schedule it out is fine with me, no problem. Okay, so taking a look at this work, you'll see that we're going to look at a little bit of stuff in the course overview unit, and then we're going to get into our first work unit, which is software development and architecture. Now one thing you'll see that the units have these long titles, but in the course structure the units have been abbreviated. So software development and architecture you can see right here, and then everything it says SDA means software development and architecture. Same thing as we move further along. Fundamentals unit, everything has F at the beginning of it for fundamentals unit, but we'll get to that later on. Okay, so back to our course home so we can look at the work again. So we're going to do the Class Connect write-up as a big part of this, so I'm going to go ahead and show you the process for the Class Connect write-ups. So I'll just scroll down until I find week 2 Class Connect write-up. Here it is. In week 2 Class Connect write-up, I've mentioned this in week 1, I believe I did. But the way the write-ups are done, you just copy and paste these questions into a word processor document. Then you find the answers from the recording, and I'll actually show you the answers today. Then you'll write your answers directly below each item. Make sure your spelling and everything is correct. Then you copy and paste your work into the Dropbox, and you do not attach a file. You just copy and paste the work into the right Dropbox. So the first step for this, I want to take all of these questions like this, highlight it, copy, and then I'm going to go to a word processor document, and I paste it in there. So you can see that here's the information all ready to go. So as we work on this, we'll go and answer those questions. Now I'm using a different kind of recording program, and for some reason it keeps saying paused. I'll see if I can get this thing done correctly. I apologize if it seems a little bit broken up. So these are all the questions we want to answer. So let's jump right into course overview unit. What program will we use for this course is going to be the first question. So program overview unit. And you'll read down through this on your own. I'm not going to read this for you. This is just a quick overview of what you're going to use. But you can see right here the program you'll use, Visual Basic Express. So the program we're using is called Visual Basic. So this is the answer. Visual Basic Express is what you'll want to put in to that Word document right here. So what program will we use for this? Whoops, Visual Basic Express. So that's how you'll do all of these things. And then again, once you have these finished, then you copy and paste So once you have the answers in for these, then you copy and paste all of these and you put them right into the Dropbox, the appropriate Dropbox. Okay, what is definition of programming? So I just look ahead at that question, of course. So this tells you a little bit more about the program that you'll be using. Okay, the course description. So the description for this course, so you have a quick overview of the System Development Lifecycle, SDLC. Then you learn about VBNet and programming and such. I'm sorry, I should have. Some of the objectives, so look at the basic components of programming, software development process, look at different architectures in building software, the best architecture to use to solve a problem, the power of the .NET, which is Microsoft.NET, VB.NET that we'll be using, different types of applications that .NET supports, build, compile, and execute programs, and debug programs. So that's what this whole course is going to be about. Now this says a getting to know you discussion. You're going to skip this. In fact, you probably won't even see it. It shows up on my screen over here, but you probably won't even see it. Lots of these things, as many of you know, we cannot edit these. We can't take these things out. So I'll just have in the gradebook, it'll say which things you need to do. So if it's not listed in the gradebook, then you don't need to do it. Okay, moving on to Section A. So Section A, now we're going to start looking at Microsoft.NET. And most programming languages are difficult, but Visual Basic is simpler. That's why we're using it. Okay, programming. Programming is the process of writing, testing, troubleshooting, and maintaining code. So there's a definition of programming right there. So if I go back to my word processor document, definition of programming, I'm not going to type that in, but I'd put that answer in right there, and there's the answer. So you would just type your answer in there. Okay, the next question, what is a major feature of .NET? And as we look through this, we'll find some of the answers, but read down through this to learn a little bit more about what programming is. And again, we'll be using VB.NET, Visual Basic.NET. And programs can create powerful applications rapidly without any difficulty using VB.NET language, which is part of the .NET technologies. And the thing about this with Visual Basic.NET, you can see that you can build all kinds of applications, consoles, Windows applications, services like Sketchpad, Notepad, things like that. Those are all built with .NET type of language. As you get more into this about .NET and Visual Basic, starts talking about different components of Visual Basic. And that one question was, why is Visual Basic so easy? We'll see that answer here. Let me go back to that. The question was, what is a major feature of .NET? I don't think we've answered it yet. I think it's on the next one. But read down through this, learn a little bit more about .NET and how it works, but you'll see that the whole basic idea behind this is you create a program, then you compile the program. And compile it is what converts it into the right language. So you design it, then you compile it, and then the program can run. Now some of these things down here you're going to need to know, so you ought to be taking notes about this stuff. And especially what these abbreviations, what they stand for. CLR, Common Language Runtime. So you want to take some notes, write that stuff down. There's some basic rules of good programming. So, of course, one of the most basic one is that you need to communicate your intentions within your code. So the code you use needs to tell the program what to do. The program isn't going to think by itself and figure out what to do. Whatever you type in, you tell it what to do. Whenever you create a program, you have to document it. So at the top of the programs, you'll put specific information, and you'll learn how to do that. Whenever there's an error, make sure you read it thoroughly, because that error will tell you obviously what's wrong. So when you compile it and then try to run it, it'll tell you what the problem is. Then the last thing about this that's really interesting is you put code into a program, you can add comments. That tells people who are reading the code, that tells them what is happening within the program. So beware of those basic rules, and as you do your programming in here, then we'll share some of those and learn a little bit more about some of those basic rules. Here's a little programming activity, just following up on the reading you just did. And then there's a discussion. It says getting to know you. Again, you're going to skip that discussion. Don't worry about that. Now, we still didn't find the answer to that one question, which is why Visual Basic is so useful, or the .NET. Let's go back to find that. So it says, so really this is main advantage is that .NET can be used to build a broad range of applications. So that's going to be your answer to that one. .NET can be used to build a broad range of applications. We did section B, so now we're finished with course overview. Now we're jumping into software development and architecture. And when we jump into this, I need to obviously go back to my word processor because I want to see the other question we have. What is the term used for development of software, and how is it abbreviated? Development, how is it abbreviated? So let's go take a look at that. So software development and architecture. And it's a process in any kind of software work that you do. So as we start looking at that, software takes this whole process: planning, analyzing, designing, and testing. And that whole process is called the software development life cycle, or the system development life cycle. They didn't have life cycle at the end, so it's really SDLC. And we'll just go with software development life cycle. So that's the answer to that last question. So software development life cycle. So let's go back to our word processor. Software development life cycle right here. So of course you're going to write out the term and the abbreviation. Okay, the 5 steps for the waterfall method. So we want to keep that in mind. The objectives for this section is you're going to look at the software development life cycle, the different phases of it, 3 alternatives to software development life cycle model, at least 1 alternative to waterfall method, advantages and disadvantages of different models. You'll look at what flowcharting is, and difference between single and multiple tier program architecture. And it sounds kind of confusing, but it will not be confusing as you go through the presentation. Of course, this shows all the assignments, but as I've said before, we are not doing all of these assignments, nor are the assignments that we're doing going to be worth the points that are listed here. Always, if you have any questions about the work, go to the grade book. That'll tell you exactly what work is due and the points that it's worth. Okay, the planning process. Now this is a discussion. We're skipping the discussion, so you'll see from the work for the week, we're skipping this, so don't worry about that. Okay, moving into section A. The systems development life cycle or software development life cycle. And I'm sorry that they use those two terms. You know, they kind of focus on software development life cycle, then they have this unit that says system development. So as long as you know that they're the same thing, that'll be fine. But you can see that the way it works is that first you have to look at the needs that you have for the program. Why are you doing the program? Design what the program might do, what it might look like, do all the coding for it, test it, and then actually there should be an arrow that goes back here to coding again, because you test and code, then maintain it. So that's the way that the whole process works. So in this section we're going to look at how the SDLC is helpful and the different phases in SDLC. So SDLC, and you can see that it takes developers that work together. So teams of developers build software. Generally it's not just one person, but obviously with what you're going to be doing, you're just going to be one person doing this. As we move down below here, this starts talking about the waterfall method. And the waterfall method, there are 5 steps, and each step is completed before you move on to the next one. So you can see here are the 5 steps. So the requirements and the analysis, the design, the coding, the testing, the maintenance. So that's the waterfall method. So that was the one question. I said, what were the steps involved in the waterfall method? Well, there you go. And the great thing about this is that it's logical and it's sequential, so you don't just jump around. You know what's coming next and you know what you're going to be doing next. That's why it's useful. So if we go back to our word processor document, I just gave you the answer for the waterfall method, so you do that. And the next one, 3 alternatives to waterfall. Next one. Okay, moving along. And we haven't gotten that, we're not going to get that answer right now, but we want to go through these different things. So this one, the steps involved in processing. So, you know, what do you do when you decide to go on a trip? When you decide to go on a trip, you plan where you're going to go, then you have to figure out what you're going to take and all that stuff. So if we click here, and this talks about a discussion, but you skipped it, but you know, in the planning process for going on a trip, there's certain steps you take. Well, similarly with software developers, there's certain steps you take in order to get to your goal. And obviously the ultimate goal for programmers is to have a program that works. So think of it as a project and that has a specific process. So, like if you're going to go on a trip, you think about your destination, you gather information and things like that. Well, software development, same thing. You're gathering information. So the requirements phase. So what are the requirements for the program, for the software you're going to create? So that data you're going to start getting together as part of that waterfall method. And you can see down here, once you've gathered it, then you understand the issues that the program has to solve, the problems it has to solve. Then you think about the design. Now this might look a little bit complicated over here, don't let it upset you, but the design you have to think about, and the design of a software program might be like if you're going on a trip, like the itinerary, what you're going to be doing on your trip. So the design of the program is going to be what the program will look like, how the program will flow. And this is all done in what's called the design phase. You can see it's which the developer decides the components or the elements of the software. And there are different layers. There's the presentation layer, so you can see what the person using the software will see. I mean, what is it going to look like when they start running the software? Then there's the logic layer, which what rules the program follows. Then finally the data layer. How does the program go through the steps, and what input, what output does it give you? So those are the different layers that you'll have as you design. Then of course the coding and testing. So this really tells you, how you're going to get to where you want to go with that program. So the coding, that would be where you write the commands for the programming language. And once you write those commands, then obviously you need to test it. So you run the program to see if it works right. So these are all part of that phase. And then finally the maintenance phase. Maintenance is to check changing the code if the requirements change and different things like that. So you know how software changes so much so quickly. These days maintenance is really a major important part of programming. Probably wasn't as important 20 years ago, because 20 years ago you'd make a program and it would last for 2 or 3 years. Now you have new versions of programs coming up, updated versions coming out, you know, once a year or twice a year. So maintenance is really important, obviously. So here's a little practice activity to see what you know about the waterfall method. So go through that on your own. Then number 10, this is going to be your first quiz. And I don't have them posted over here yet, but I will have quiz previews posted over here. So don't take the quiz yet. Wait till I get the quiz previews posted. Alright, section B. In section B, we're going to look at the alternatives to SDLC. And that was the next question on that Class Connect. So waterfall is used by many programmers, but there are other methods such as the software prototyping, rapid application development, and object-oriented. So there are 3 models right here. And that was what that question was. What are 3 models? So you're going to understand what software prototyping is, explain how rapid application is used, and several concepts of object-oriented. You're going to learn all of those things in this section. So software prototyping. In this one, the coding takes place once you get the requirements, then the customer tests the software and gives the developers comments. So this is a little bit different. So you can see in this one you say, okay, here's what we've made based on the requirements you have. Tell us if it does what you want it to do. Then the customer gets back and says, no, we need to have it do this or do that. So it's a little bit different because you have customer input. But the thing about it, if you look down here, it's difficult to use because you have to gather the customer's information. And sometimes it's hard for them to tell you exactly what they want. But it is another method. So this is one method that one would use. Either rapid application development. This is the second method. So this was after the waterfall method came along. But the waterfall method was kind of slow. So in this rapid application, obviously the word rapid means fast. But in this one, they use like multiple reviewers before the development is completed. So in this one, they go through this process right here much more quickly before they jump into the main testing process. And some advantages: a program can use previously developed software, and they can put off the designing and coding the advanced features in the beginning. So it's faster development, but some features aren't full, like it says right here, not fully developed when it's first used. So this is an adjustment to the waterfall method, just a faster waterfall method. And finally, object-oriented is centered around the idea of an object. And in programming, an object, it's a single thing or a single thing that happens in a program. And we'll be doing object-oriented a lot in this class. So the thing you need to think about, a collection of objects is a class. So think of that, a collection of students in a room, or a class of students. So a collection of objects is a class. And in programming, when you focus on an object, you reuse your code for other parts of the program. And we'll learn a lot about object-oriented programming in this class. So those were the 3 methods. Here's a little tutorial you can go through to learn about class and object. Here's another discussion on models. And again, you are not doing the discussions, so don't worry about that. Another quiz, and you will do the quizzes obviously, and I'll have, as I said, the quiz previews posted down here. And finally, number 9, research activity. So you'll do this research activity, and this says you've learned about different types of models, but then you're going to go and do a little bit of research to find other models. And make sure you use a bibliography showing me where you got your information. And don't just copy it word for word. I want to have it in your own words, please. Okay, let's go back and look at our word processing, our class connect. Through alternative, define the term program flow. Okay. So you'll finish up the research part, and then you move on to section C. In section C, we're going to start talking about program flow. And program flow, it's fairly easy to know, but to think of what it might mean. But if you look down below here, program flow are the steps and the order in which they occur. That's the program flow. So it's almost like, as this shows making a recipe. You do it a step at a time. Particular things come before other things happen. Or like if you're going to start a car. First you get in the car, then you put the key in the ignition, then you turn the ignition key. So those are the steps involved. Well, programming, same thing. Programmers have to think about the steps of a program before they start to arrange the code, because if the code is out of order, the program won't work right. Same with the recipe. If you do things out of order, let's say if you mix water and flour first before you put the eggs in, you can come up with paste rather than dough that you could use to make bread or cookies. So the program flow is very important. So that one Class Connect question, program flow are the steps and the order in which they occur. Steps of a program and the order in which they occur. That's program flow. At page 2, in this section, you're going to look at the basics of program flow, draw a flow chart, arrange tasks in logical order, explain event and event-driven programs, and discuss difference between sequential, which means a step-by-step program, and event-driven programming. Okay, program flow. So this says, think about the process for adding two numbers. How could you tell a computer to do this? Well, the first thing you do is you'd probably have the program start, and then you would say, type in right here, what would you do? So what are the steps? Get number, or get first number, right? So we're adding two numbers, so get first number. Okay, what is going to be the second step that we would take? Get second number. What would be the third step that we would take? Add the two numbers. I'll just put add the numbers. So add the numbers. Then finally, print answer. So you can see that this is the program flow to add two numbers together. And you tell the computer to get the numbers, add them together, print the answers. So it's really important. You could write this down for your notes, but it's really important to think about how the program flow works. And this is what's called a flow chart. You'll be working with those a little bit as we move along. So now we can see the answers to this. So read the numbers, add them, print the results, right? Now here's another way down below. This is a more advanced way, but if you look at the one down below, in this one, start, and then you set a counter to 0. And check if the counter is less than 0. Is the counter less than 0? Yes. Then give me a number, program says. Then the program comes back here and it says, well, is the counter less than 2? Yes, it is. Okay, give me another number. So now it's been given two numbers. So then the program comes back here. Is the counter less than 2? No. So now it will add all the numbers, then it will print the results. So you can see where this method is different from this method. Now the nice thing about this one is that in this method is that if I wanted to change this to where it would add up 3 numbers, 4 numbers, 5 numbers, 27 numbers, all I'd have to do is go right here and change that coding. And then it would go all the way up to 27 or 100 or 1,000,000, whatever it is. And then it would add up all those numbers. This one up here, I would have to say, put a line like this in. Read the third number, read the fourth number, read the fifth number, read the sixth. Take a lot more programming to do this. So it's much easier to have activities that happen many times to do them with, this is kind of called an if-then statement. So pay attention to these two methods because that's the last question on the Class Connect write-up. Okay, moving on, let's finish up section C. So now you're going to learn a little bit about flowcharting here. So you learn how to draw a flowchart. We move into sequential logic. So sequential logic. So look up here, 2, 4, 6, 8. What comes next? Obviously it's going to be the number 10, right? And you knew that because you were going in sequence. You were adding 2 each time. That's called sequential. So a math series is sequential logic, meaning step by step. And most programs are going to be sequential. So they receive the input, perform calculation, print the results. That's what sequential means, going in order. Okay, here's an idea about events and what events do. And events, you see right there, an event is something done by the user or by the program. So an event could be a click of a mouse. An event could be the program printing a display or adding numbers, many different things. And events and programs are called an event handler. And we'll learn about that. What the event handler does is it holds the information as it starts to process it. Now this is event-driven programming. So remember the last time when we looked at that first model, it was just one step at a time. This is event because it goes down here, and this is the event right here. The computer has to make a decision, yes or no, to make other things happen. So you can see how event-driven are different from sequential. An event is what's called if-then logic. So if one thing happens, then do this. So right here, if n divided by 2 is less than 0, if it's yes, then do this. If it's no, then do this. Okay, area of a triangle flowchart. So you're going to make a flowchart. It's going to be one of your assignments to turn in. So you can see, to get the area of a flowchart, you take 1/2 of the base times the height. So what things are you going to ask, what is the computer going to have to do? Well, it's going to have to ask the user for what is the base of the triangle, what is the height of the triangle. Then once it does those, then it multiplies those two things by 1/2. Then it prints out area. So this will be fairly similar to the adding two numbers program that we looked at earlier. But you're going to use this formula. That's going to be one of your steps, this formula right here. So you're going to go ahead and create this flowchart, and you'll turn in that assignment. So this will be about, remember you need to have start as your first command, then what is base, what is height, and you can figure this out. And of course print the result. Now here's some flowchart practice. Here's obviously a really advanced flowchart. This is a flowchart if somebody's placing a telephone order, like something you want to buy, and you're placing a telephone, placing it over the phone. You can see your starting and end piece parts, the action steps, the decisions, and then the whole workflow is by the arrows. So if you take a look at this, how many events are there? How many end user decisions have to be made? Do you think it'd be handled by a computer program? Why or why not? Are there any if-then or logic steps in it? So go through this. It's kind of interesting. Confirm that the orders be ready. Fill in the buyer's info. Once that's done, then you go up here. Does the buyer have a purchase order? No. Well, then you need to go through all these steps. If they do have a purchase order, that means they're ready to buy. Then they're going to fill in the purchase order. So go through this, kind of figure out the steps that this goes through, and answer these questions if you can. If you click on them, the answers will show up, but see if you can answer them yourself. Okay, program flow quiz. Again, I'll have the quiz previews over here for you, so you can do the quizzes more easily. So that's it. That is all for this week. So right at the end of Class Connect write-up, program flow quiz, that was all. So now if I go back, I'm going to go back to that Class Connect write-up. And again, I had it in that word processed and we looked at it. So I showed you where all the answers to these were. So again, what you'll do, you'll take those answers, you'll copy and paste your work right in the appropriate Dropbox, but do not attach a file. If you attach a file, I'll get mad, because I tell you clearly right here, do not attach a file. So you just copy and paste these right into the Dropbox. And that is all for this week. Just go back to Course Home, take a quick look at Week 2 work. We just covered all of this information. Okay, thanks everyone. Have a great week. I look forward to your work coming in. Bye.